We are going to look at arc length and the unit tangent vector t, and we are interested in the arc length along a space curve. One of the features of smooth space curves is that they have a measurable length. This enables us to locate points along these curves by giving their directed distance s along curves from some base point, the way we locate points on coordinate axes by giving their directed distances from the origin. Time is the natural parameter for describing a moving body velocity and acceleration, but s is the natural parameter for studying a curve's shape. Both parameters appear in analysis of a space flight. To measure distance along a smooth curve in a space, we add a z term to the formula we use for these curves in the plane.
And let's begin with the definition of finding arc length of a space curve. If rt is a function which has 3 points x, y, z, which is continuous, then we know the distance traveled along the graph, which is L from t equals to a to t equals to b, by using the formula below by integrating rt from interval a to b. Also, the arc length is known as the integration of the vt function. Let's find the arc length for the helix as shown below, which is rt equals to cos t plus sin t and t. This is the graph for the function. Let's say we want to find t from 0 to 2 pi. By using the formula shown earlier, we integrate the function rt from interval 0 to 2 pi. First, we square the function and we will get this. Since sin 2x plus cos 2x equals to 1, we get pi over 2, and by that we integrate with t, and finally we get the length of the arc, which is square root of 2 times the circumference of the circle in the xy plane over which the helix stands. Next, let's talk about speed. We can find a speed, for example, a glider or a projectile, by integrating vt. In other words, we get this by differentiating st, which is the change in arc length over change in time. Earlier from the question, we know that the arc length function, which is the integration of square root 2. Therefore, by integrating this function again with respect to t, we get square root over 2t. Therefore, by substituting any value of t, the time, we will know the speed of it. And lastly, let's discuss about unit tangent vector, which is also known as t. The unit tangent vector is a differentiable function of t whenever the velocity vector is a differentiable function of t. Unit tangent vector is one of 3 unit vectors in a traveling reference frame that is used to describe the motion of objects traveling in 3 dimensions. We already know the velocity vector is tangent to the curve rt, and therefore vector is v divided by the magnitude of velocity vector. Let's look at this example rt. By differentiating it, we will get the velocity of the function. Then we find the magnitude of vt. So at last, to find the unit tangent vector, we just divide the velocity vector over the magnitude of the vector. After that, to find the unit tangent vector when time is equal to 0, we simply substitute the value to the function, and therefore we get the unit vector. So that's it. In this subchapter, we first learn how to find the length of the smooth curve, then the speed of it, and lastly the unit tangent vector. Okay, thanks for watching, and remember to comment. Bye.